Let's talk about linear functions or linear equations. Functions, equations, I'm going to use those words kind of interchangeably in this video. Know that they do have technically different definitions, but for our purposes, we will use them as if they're the same thing. The differences are not important for this video. So we're going to talk about linear functions or linear equations. We're going to talk about understanding them. So just kind of the basic components of linear functions, linear equations. What information do we need in order to visualize or represent or graph these linear functions? And what do those quantities and numbers and coefficients and things really mean? And that's what we're going to talk about. The first part of a linear function is the independent variable. And a linear function will have actually two variables because it's two-dimensional. It's going to be on a two-dimensional graph like this. So it's going to have two variables, and each variable represents a different dimension or a different axis. So the first one to be familiar with is the independent variable. And this can be referred to in a number of different ways. Input is a common term that we use for it, especially when we're talking about functions. In physical terms, it's the horizontal axis. It's going to be the axis running across from left to right or from right to left. We also refer to it as the x-axis or the x variable. So when you see a linear equation and you see that x is what we would call the independent variable. I also refer to this sometimes as the cause, and that's getting into kind of more the logic. Once I have two variables, how do I determine which one is independent and which one is, spoiler alert, dependent? And I think about them as cause and effect. Especially if you're designing a scientific experiment. And I know this is really oversimplifying it. So if you know more than I do, please don't be upset. But I think about it as cause and effect, where independent variable is the cause, and then the dependent variable is the effect. So with the independent variable, we'll graph it horizontally. In this case, it's going to go across the bottom of our graph. Now, the second variable, and I already mentioned this, is the dependent variable, and that's going to be the vertical axis. If independent variable is the input, then the dependent variable is the output. If the independent variable is the horizontal axis, then the dependent variable is the vertical axis. If the independent variable is the x, the dependent variable is the y. If the independent variable is the cause, the dependent variable is the effect. So cause and effect, x and y. Those are our two variables, and we need to be able to identify both of those variables, especially if we have a word problem. If we have some kind of a word problem that's being represented by a linear equation or a linear function, I need to understand logically how these two variables are related, and I need to be able to identify the two variables. Once I have that, those are kind of the basics of the linear function, but don't actually themselves make up the linear function. We need to know what the variables are so that we know what we're talking about. But the actual specifics of the linear function are the next two things that I'm going to talk about. And the first is rate of change. This can also be referred to as the slope. It's important to note that this is a ratio. It's a ratio of two numbers. And it will usually be written as a fraction. It's vertical change over horizontal change as a ratio. It's change in y over change in x, or rise over run. In a word problem, this will be represented by the words like for each, or for every, or per. If I'm talking about miles per hour, I could graph that, and the graph would probably look like this with a blue line going up. If I was talking about miles per hour, I'm talking about miles. That would be my effect, my y per hour, and that would be my x, my horizontal. So miles per hour is a ratio, and I can represent it in a rate of change. And it's talking about the definition that I give my students for rate of change is that it's a ratio that describes how quickly the y value increases or decreases as the x value increases. So as x is increasing, in this case, if we're talking about miles per hour, as hours increase as time goes by, how quickly are your miles increasing or decreasing? And that's going to be your miles per hour. And it's not always going to be a positive association like this. Sometimes it'll be flat. And what that says is that my Y value is not increasing or decreasing. That's if I'm stopped at a stoplight, my miles per hour are 0. And the slope of that orange line is actually 0. Or it can be negative. I can be going down as I move from left to right, like that yellow line. And that would be, I don't know if you're driving in reverse or something. My example is falling apart, but rate of change it describes kind of how steep that line is, as well as if it's positive or if it's negative or if it's totally flat. And then we have initial value. Initial value has a couple other terms: starting value or y-intercept. Y-intercept is kind of like the most abstract way of talking about it. But this is, in a word problem, this would be like an initial cost or a flat fee. And what this is describing is kind of where, it's the starting value. It's where on the y-axis the line is beginning. And it can be negative. But any line that crosses the y-axis, any function is going to have an initial value, is going to have a y-intercept. So you'll notice with the blue, the orange, and the yellow lines here that they all actually have the same slope. Notice that they're all rising at the same rate as you move from left to right. But they're different lines because they have different initial values. So the initial value is an important piece of our linear function or linear equation. It's part of what we need in order to accurately describe what's happening in the relationship. So when I put this all together into an equation, you might be familiar with what's called slope-intercept form, which is y equals mx plus b. Using different terms, the terms that I've been using in this video so far, I could also describe it as output equals rate times input plus starting value. So whatever my rate is, miles per hour, times my input, my hours, plus starting value, maybe if I already had some distance traveled. If I add all of that together, then I'm going to get my output, which is miles, which is how far I've traveled. So that's how it all kind of fits together, and that's why you need all 4 of those parts. You need the independent variable or the input. You need the dependent variable or the output. You need the slope or the rate or rate of change, and you need your y-intercept or your starting value. You need all 4 of those pieces in order to create an accurate equation to represent what's going on. So let me give you an example. Something totally ridiculous that I made up, but this illustrates what we're talking about. Let's say Joseph finds half a pound of gold in his shoe every year on his birthday, January 31st. When he was born, a strange man appeared and gave him 10 pounds of gold. How many pounds of gold will Joseph have by the time he is 30? So here we have different things, and obviously this is a totally ridiculous scenario, but we have these different pieces. We actually do have a 2 variables. Maybe you can see what they are. We have 2 variables. We have a rate and we have an initial value. So let me display the equation for you so that you can see what I'm talking about. Okay, so here's the equation. Gold equals 1/2 times years plus 10. And maybe you could already kind of have guessed this. You could have already figured this out. But this equation represents what just happened. And it has all 4 of those parts. You can see gold is going to be my output, years is going to be my input, and so on. So let's graph this. Let's say to start with, years is my cause. That's going to be my horizontal axis, my independent variable. So it's going to be horizontal here. That's going to be years. Gold is my output. That's the effect. If years is the cause, gold is the effect. So that's going to be my vertical axis. Now, I also have my rate and my initial value. So my initial value 10 tells me my line is going to start at 10. On the y-axis, my line is going to start at 10. And I don't have it labeled, but imagine this line is starting at 10. And then as it moves from left to right, it's going to go up half a pound each year. So it's not starting at 0 because I didn't start with 0 pounds of gold. I started with 10. And then as it moves from left to right, it's going to go up 1/2 pound each time it goes right 1 year. So all of those things kind of come together to describe what this line looks like. Now, if I was getting more gold per year, the line would be more steep. It would be rising more quickly. Or if I was losing gold every year, it would be going down. It would be falling as it moved left to right. But there you can kind of see how all 4 of these pieces kind of come together to help us know how to graph, how to visually represent this linear function. So I hope that this video was helpful and informative. If you guys have any questions, anything else that you would like to know about linear equations, I know this was very brief, but this was meant to be just kind of an introduction to these ideas. If you guys have any other questions or anything else that you would like me to talk about, please let me know. Thank you.